Hello viewers, welcome to my channel Online Biology Tutorials. I hope the screen is visible and clear to everybody. In this live of today, we will be reading chapter 12, Some Natural Phenomena from NCERT Class 8 that is used in CBSE board. In case you are interested in hearing the audio of first 11 chapters, you can come to the playlist of my channel with the name Audiobook Class 8 Science. There you will find all the videos starting from chapter 1 to chapter 11. In this chapter, we shall discuss two destructive natural phenomena. These are lightning and earthquakes. We should also discuss what steps we can take to minimize destruction caused by these phenomena. 12.1 Lightning. You might have seen sparks on an electric pole when wires become loose. This phenomenon is quite common when wind is blowing and shaking the wires. You might also have seen sparks when a plug is loose in its socket. Lightning is also an electric spark, but on a huge scale. In ancient times, people did not understand the cause of these sparks. They were therefore afraid of lightning and thought that the wrath of gods was visiting them. Now, of course, we understand that lightning is caused by the accumulation of charges in the clouds. We need not to be afraid of lightning, but we have to take precautions to protect ourselves from the deadly sparks. The sparks that the Greeks knew about. The ancient Greeks knew as early as 600 BC that when Amber is a kind of resin was rubbed with fur. It attracted light objects such as hair. You might have seen that when you take off woolen or polyester clothes, your hair stands on end. If you take off these clothes in the dark, you even see a spark and hear a crackling sound. In 1752, Benjamin Franklin, an American scientist, showed that lightning and the spark from your clothes are essentially the same phenomena. However, it took 2000 years for this realization to occur. I wonder why they took so many years to realize the similarity. Scientific discoveries are a result of hard work by many people. It can sometimes take a long time. We shall now study some properties of electric charges. We shall also see how they are related to the lightning in the sky. Let us perform some activities to understand the nature of electric charges, but recall first what you might have played as a game. When you rub a plastic scale on your dry hair, the scale can attract very small pieces of paper. 12.2 Charging by rubbing. Take a used ball pen refill and rub it vigorously with a piece of polythene. Bring it close to small pieces of paper. Take care not to touch the rubbed end of the refill with your hand or with a metallic object. Repeat the activity with small pieces of dry leaf, husk, and mustard seeds. Record your observations. When a plastic refill is rubbed with polythene, it acquires a small electric charge. Similarly, when a plastic comb is rubbed with dry hair, it acquires a small charge. These objects are called the charge objects. In the process of charging the refill and the plastic comb, polythene and hair also gets charged. Let us try to charge some other objects that are familiar to you. So in activity 12.2, collect the objects and the materials listed in the table 12.1. Try to charge each by rubbing with the materials mentioned in the table. Record your findings. You can add more items to the table. Table 12.1 Objects rubbed could be refill. Material used for rubbing polythene woolen cloth. Objects rubbed balloon. Material used for rubbing polythene woolen cloth dry hair. So you need to find out whether they are attracting or not attracting, charged or uncharged. So similarly you need to find for eraser when it is rubbed with wool, steel spoon when it is rubbed with polythene or woolen cloth. Next page. So here we go. 12.3. I think now the orientation of the screen is clear to everybody. 12.3 Types of charges and their interaction. We will Select some objects from table 12.1 for the next activity. A. Inflate two balloons, hang them in such a way that they do not touch each other in figure 15.1. Rub both the balloons with a woolen cloth and release them. What do you observe? Now let us repeat this activity with the use of pen refills. Rub one refill with polythene, place it carefully in a glass tumbler using the tumbler as a stand. This is shown here. So in figure 12.2, interaction between the like charges has been shown to you. Rub the other refill also with polythene. Bring it close to the charged refill. Be careful not to touch the charge end with your hand. Is there any effect on the refill in the tumbler? Do the two attract each other or repel each other? In this activity, we have brought close together the charge objects that were made of the same material. What happens if two charge objects made of different materials are brought closer to each other? Let's find out. B. Rub a refill and place it gently in a glass tumbler as before. As seen in figure 12.3, bring an inflated charged balloon near the refill and observe. Let's summarize the observations. A charged balloon repelled a charged balloon. A charged refill repelled a charged refill. But a charged balloon attracted a charged refill. Does it indicate that the charge on the balloon is of a different kind from the charge on the refill? Can we say then that they are two kinds of charges? I hope the screen is clear. Charges, can we also say that the charges of the same kind repel each other while charges of different kind attract each other? It is a convention to call the charge acquired by a glass rod when it is rubbed with silk as positive. The other kind of charge is said to be negative. It is observed that when a charged glass rod is brought near a charged plastic straw rubbed with polythene, there is attraction between the two. What do you think would be the kind of charge on the plastic straw? Your guess that the plastic straw would carry a negative charge is correct. The electric charges generated by rubbing are static. They do not move by themselves. When charges move, they constitute an electric current. You have been reading about electric current since class 6. The current in a circuit which makes a bulb glow or the current that makes a wire hot is nothing but a motion of charges. 12.4 Transfer of charge. Activity 12.4. Take an empty jam bottle. Take a piece of cardboard slightly bigger in size than the mouth of the bottle. Pierce a hole in it so that a metal paper clip can be inserted. Open out the paper clip as shown in figure 12.4. Cut two strips of aluminium foil about 4 cm into 1 cm each. Hang them on the paper clip as shown. Insert the paper clip in the cardboard lid so that it is perpendicular to it as seen in figure 12.4. Charge a refill and touch it with the end of the paper clip. Observe what happens. Is there any effect on the foil strips? Do they repel each other or attract each other? Now, touch other charged bodies with the end of the paper clip. Do foil strips behave in the same way in all the cases? Can this apparatus be used to detect whether a body is charged or not? Can you explain why the foil strips repel each other? Figure 12.4, a simple electroscope. The aluminium foil strips receive the same charge from the charge refill through the paper clip. Remember that metals are good conductors of electricity. The strips carrying similar charges repel each other and they become wide open. Such a device can be used to test whether an object is carrying charge or not. This device is known as electroscope. Thus, we find that electrical charge can be transferred from a charged object to another through a metal conductor. Touch the end of the paper clip gently with hand and you will find a change in the foil strips. They come back to their original state. Repeat charging of foil strips and touching the paper clip. Every time you will find that the foil strips collapse as soon as you touch the paper clip with hand. Why does it happen? The reason is that foil strips lose charge to the earth through your body. We say that the foil strips are discharged. The process of transferring of charge from the charged object to the earth is called earthing. Earthing is provided in buildings to protect us from electrical shocks due to any leakage or electrical current. 12.5 The story of lighting. It is now possible to explain lighting in terms of the charges produced by rubbing. So, in figure 12.5, accumulation of charges leading to lightning has been shown to you. During the development of a thunderstorm, the air currents move upward while the water droplets move downward. These vigorous movements cause separation of the charges. By a process not yet completely understood, the positive charges collect near the upper edges of the cloud, and the negative charges accumulate near the lower edges. There is accumulation of positive charges near the ground also. When the magnitude of the accumulated charges becomes very large, the air, which is normally a poor conductor of electricity, is no longer able to resist their flow. Negative and positive charges meet, producing streaks of bright light and sound. We see streaks as lightning. The process is called as electric discharge. This page now. The process of electric discharge can occur between two or more clouds or between clouds and the earth. Today we need not get frightened by lightning like our ancestors did. Now we understand the basic phenomenon. Scientists are trying hard to improve this understanding. However, lightning strike could destroy life and property. It is therefore necessary to take measures to protect ourselves. 12.6 Lightning safety. During lightning and thunderstorm, no open place is safe. Hearing thunder is an alert to rush to a safer place. After hearing the last thunder, wait for some time before coming out of the safe place. Finding a safe place. A house or a building is a safe place. If you are traveling by car or by bus, you are safe inside with windows and the doors of the vehicles shut. Do's and don'ts during a thunderstorm. Outside, open vehicles like motorbikes, tractors, construction machinery, open cars are not safe. Open fields, tall trees, shelters in parks, elevated places do not protect us from lightning strokes. Carrying an umbrella is not at all a good idea during thunderstorms. If in a forest, take shelter under shorter trees. If no shelter is available, you are in an open field, stay far away from all the trees. Stay away from poles or other metal objects. Do not lie on the ground. Instead, squat low on the ground. Place your hands on your knees with your head between your hands. This position will make you the smallest target to be struck. Figure 12.6 is showing you the safe position during lightning. Inside the house, lightning can strike telephone cords, electrical wires, and metal pipes. Do you remember lightning is an electrical discharge? During a thunderstorm, contact with this should be avoided. It is safer to use mobile phones and cordless phones. However, it is not wise to call up a person who is receiving your phone through a wired phone. Bathing should be avoided during thunderstorms to avoid contact with running water. Electrical appliances like computers, TV should be unplugged. Electrical lights can remain on. They do not cause any harm. Lightning conductors. Lightning conductor is a device used to protect buildings from the effect of lightning. A metallic rod taller than the building is installed in the walls of the building during its construction. One end of the rod is kept out in the air and the other is buried deep in the ground, as seen in figure 12.7. The rod provides easy route for the transfer of electric charge to the ground. The metal columns used during construction, electrical wires, and water pipes in the building also protect us to an extent, but do not touch them during thunderstorm. So, in figure 12.7, lightning conductor has been shown to you. 12.7 Earthquakes. You just learned about thunderstorm and lightning. These natural phenomena can cause large scale destruction of human life and property. Fortunately, these phenomena can be predicted to some extent. The weather department can warn about a thunderstorm developing in some area. If a thunderstorm occurs, there is always a possibility of lightning and cyclones accompanying it. So we get time to take measures to protect ourselves from the damage caused by these phenomena. There is, however, one natural phenomena which we are not yet able to predict accurately. It is an earthquake. It can cause damage to human life and property on a huge scale. A major earthquake occurred in India on 8th October 2005 in Uri. Tangdhar towns of North Kashmir, figure 12.8. Before that, a major earthquake occurred on 26 January 2001 in Bhuj district of Gujarat. So, Kashmir earthquake, the destruction has been shown to you in figure 12.8. Activity 12.5. Ask your parents about the huge damage to life and property caused by these earthquakes. Collect a few pictures showing the damage caused by these earthquakes from newspapers, magazines of those days. Prepare a short report on the suffering of the people during and after the earthquakes. What is an earthquake? What happens when it occurs? What can we do to minimize its effects? These are some of the questions which we shall discuss below. An earthquake is a sudden shaking or trembling of the earth which lasts for a very short time. It is caused by a disturbance deep inside the earth's crust. Earthquakes occur all the time, all over the earth. They are not even noticed. Major earthquakes are much less frequent. They can cause immense damage to buildings, bridges, dams, and people. They can be great loss to life and property. Earthquakes can cause floods, landslides, and tsunamis. A major tsunami occurred in the Indian Ocean on 26 December 2004. All the coastal areas around the ocean suffered huge losses. Activity 12.6. Take an outline map of the world, locate the eastern coast and Andaman and Nicobar Islands in India. Mark other countries around the Indian Ocean which could have suffered damage. Collect accounts of the devastation caused by the tsunami in India from your parents or other elders in the family or in the neighborhood. What causes an earthquake? My grandmother told me that the earth is balanced on the horn of a bull, and when the bull shifts it to the other horn, an earthquake takes place. How could it be true? In ancient times, people did not know the true cause of earthquakes. Their ideas were therefore expressed in mythical stories, such as one told by Bojo's grandmother. Similar myths were prevalent in other parts of the world. What could cause a disturbance inside the earth? Now we know that the tremors are caused by the disturbance deep down inside the uppermost layer of the earth called the crust. Figure 12.9. Structure of the earth. The outermost layer of the earth is not in one place, it is fragmented. Each fragment is known as plate. These plates are in continual motion when they brush past one another or a plate goes under another due to collision. They cause disturbance in the earth crust. It is this disturbance that causes up as an earthquake on the surface of the earth. If scientists know so much about earthquakes, can they also predict when and where the next one will strike? Although we know for sure what causes an earthquake, it is not yet possible to predict when and where the next earthquake might occur. I read somewhere that underground explosions could also cause tremors. Tremors on the earth can also be caused when a volcano erupts, or a meteor hits the earth, or an underground nuclear explosion is carried out. However, most earthquakes are caused by the movement of the Earth's plates. Since earthquakes are caused by the movement of plates, the boundaries of the plates are the weak zones where earthquakes are more likely to occur. The weak zones are also known as seismic or fault zones in India. The areas most threatened are Kashmir, western and central Himalayas, and the whole of northeast Rann of Kutch, Rajasthan, and the Indo-Gangetic Plain. Some areas of South India also fall in the danger zone. Figure 12.12. Movements of Indian earth plate. The power of an earthquake is expressed in terms of magnitude on a scale called Richter scale. Really destructive earthquakes have magnitudes higher than 7 on the Richter scale. Both Bhuj and Kashmir earthquakes had magnitudes greater than 7.5. The tremors produce waves on the surface of the earth. These are called seismic waves. The waves are recorded by an instrument called the seismograph, seen in figure 12.13. The instrument is simply a vibrating rod or a pendulum which starts vibrating when tremors occur. A pen is attached to the vibrating system. The pen records the seismic waves on a paper which moves under it. By studying these waves, scientists can construct a complete map of the earthquake as shown in figure 12.14. They can also estimate its power to cause destruction. So this is the map of earthquake in 12.14. Like many other scales in science, decibel is another example. Richter scale is not linear. This means that an earthquake of magnitude 6 does not have 1.5 times the destructive energy of the earthquake of magnitude 4. In fact, an increase of 2 in magnitude means 1000 times more destructive energy. Therefore, an earthquake of magnitude 6 has 1000 times more destructive energy than an earthquake of magnitude 4. Protection against earthquakes. We know that earlier pages that earthquakes cannot be predicted. We have also seen that they can be highly destructive. It is therefore important that we take necessary precautions to protect ourselves all the times. Living in seismic and people living in seismic zones where the earthquakes are more likely to occur have to be specially prepared. First of all, the buildings in these zones should be so designed that they can withstand major tremors. Modern building technology can make it possible. It is advisable to make the structure simple so that it is quick, safe. Consult qualified architects and structural engineers. In highly seismic areas, the use of mud or timber is better than using heavy construction material. Keep roofs as light as possible in case the structure falls, the damage will not be heavy. It is better if the cupboards and shelves are fixed to the wall so that they do not fall easily. Be careful when you hang wall clocks, photo frames, water heaters, etc., so that in the event of any earthquake, they do not fall on people. Since some buildings may catch fire, excuse me, since some buildings may catch fire due to an earthquake, it is necessary that all the buildings, especially the tall buildings, have fire fighting equipment in working order. The Central Building Research Institute Roorkee has developed somehow to make quake resistant houses. In the event that an earthquake does strike, take the following steps to protect yourself. 1. If you are at home, take shelter under a table and stay there till the shaking stops. Stay away from tall and heavy objects that may fall on you. If you are in bed, do not get up, protect your head with a pillow. 2. If you are outdoors, find a clear spot away from buildings, trees, and overhead power lines. Drop to the ground. Just wait. 2. If you are outdoors, find a clear spot away from buildings, trees, and overhead power lines. Drop to the ground. If you are in a car or a bus, do not come out. Ask the driver to drive slowly to a clear spot. Do not come out till the tremors stop. So, with this, we are done with the reading of Chapter 12, Class 8 Science. The keywords used in the chapter are crust, discharge, earth's plates, earthquake, electroscope, lightning, lightning conductor, negative charge, positive charge, Richter scale, seismograph, thunder, thunderstorm, transfer of charge, tsunami, tremor. Some objects can be charged by rubbing with other objects. There are two kinds of charges, positive charge and negative charge. Like charges repel and unlike charges attract each other, the electrical charges produced by rubbing are called static charges. When charges move, they constitute an electric current. An electroscope may be used to detect whether a body is charged or not. The process of transfer of charge from a charged object to the earth is called earthing. The process of electric discharge between clouds and the earth or between different clouds causes lightning. Lightning strikes could destroy life and property. Lightning conductors can protect buildings from the effects of lightning. An earthquake is a sudden shaking or trembling of the earth. Earthquake is caused by a disturbance deep inside the earth's crust. It is not possible to predict the occurrence of an earthquake. Earthquakes tend to occur at the boundaries of earth plates. These boundaries are known as fault zones. Destructive energy of an earthquake is measured on the Richter scale. The earthquake measuring 7 or more on Richter scale can cause severe damage to life and property. We should take necessary precautions to protect ourselves from earthquakes. So, with the reading of the summary, I am done with the reading of chapter 12, Some Natural Phenomena, taken from NCERT Class 8 used in CBSE board. In case you are interested in hearing the audio of the first 11 chapters, already a playlist has been uploaded on my channel. Consider subscribing so that you can have the recent notifications. See you in next video. Thank you for now.